So let's revisit example C for just a little bit. Now, originally when we did this, we got the equation in kind of a standard form. So to find the vertex, we used the vertex formula, negative b over 2a. That gave us x equal negative 1. To then solve for the y coordinate, you put it into the equation for x. So we put it in and we get an x coordinate of negative 4, or y coordinate of negative 48. Great. You follow it up with the x-intercept and the y-intercepts. The y-intercept, you set x equal to 0. The x-intercepts, you set y equals 0 and solve. Everyone's happy. You get this selection of points, etc. But there's a different question I could ask out of something like this, and that is, what would the equation look like if I wrote it in a different form? That is, if I wanted to write it as, say, f of x equals a times x minus h squared plus k. How would I get it in that form if I start out in this form? Well, let me do that down here. So give myself a little room. There we go. And I'm going to start by replacing this by a y coordinate. So just for convenience, I'm going to write that as y equals 3x squared plus 6x minus 45. The right-hand side I eventually want to write as a perfect square. So this 45 doesn't fit in well with my plans. So what I'll do is I'll jettison it to the other side. Let's kick this over to the left-hand side. When it changes sides, what else is going to change?
The sign.
The sign. Perfect. So it's going to be y plus 45 equals 3 times x squared plus 6x. Now we're going to go back to the stuff from section 3.1 where we're going to complete the square. So I first need to factor out the x. I first need to factor out the 3 that's in front of this x squared. I can't just take out the 3 from this term. I got to factor out of both terms. So that leaves me with x squared plus 2x. And now I can work on factoring the square with what's inside. So it's going to be x squared plus 45 plus something equals 3 times x squared plus 2x plus something. This is where we're going to use that stuff where we did the completing the square. Ryan?
Why don't you factor out 3x?
Yeah.
Great question. Because if I factored out 3x, there wouldn't be anything left to complete the square with. I wouldn't have a quadratic in here. So I need to factor out just the 3. It's a good question. So to complete the square on this, you might remember what we did the other day. What do we do with this number here in the middle? Take half of that number in the middle. Half of 2 is 1. And then what? Then we did 1 squared, and that's still 1. So that 1 here is going to go there. That's the number that's going to make this a perfect square. The right-hand side of this is now going to be 3 times something squared. But let's be careful about what I add on the left-hand side. I'm not just going to add 1, because that 1 is inside parentheses. What's happening to that 1 along with every other term in this parentheses? Being multiplied by 3. So putting a 1 here means what should I put over here? 3. 3 times 1 is 3. So effectively by putting a 1 here, I've added 3 to the right-hand side. And in that way, I'll also add 3 to the left-hand side. Now the left-hand side is y plus 48. How about the right-hand side? What is this? Well, it comes from this up here. Can you write this a different way? Maybe as something squared?
X plus 1.
X plus 1. So it's x plus 1 squared. And now the last thing to do is to get y by itself again. So I'll move that that 48 back to the right-hand side. And as before, it changes signs. So we get 3 times x plus 1 squared minus 48. This is in what we've called the vertex form. You can look at this and pretty much read off the vertex. What makes the squared term equal to negative, or what makes the squared term equal to 0? Negative 1. And when that's negative 1, all this is 0, and that's the y-coordinate of my vertex. So negative 1 and negative 48. So it's nice to have it in that form. It takes a lot of work, I won't lie. So, I don't know. Usually I do these things as separate problems. On one problem I say, start out with something like this and put it in this form. On other problems I'll just say, graph it. Maybe I'll give you one form, the other, or both. But, you know, this is a decent problem to put on an exam. Is it the most important problem? Maybe not. But hopefully after you work with section 10.1, you can do this. Let's keep going with a few more here. I'm going to jump down to example E here, just to show you some of the other things that can happen when you're working with parabolas. So, example E, we've got f of x equals 4x squared minus 12x plus 9. Now you've got your choice. Probably the way that I would suggest you start out is by finding the equation, or finding the vertex. So you've got a choice of either using our formula, x equals negative b over 2a, or all that stuff we just went through to write it as f of x is a times x minus h squared plus k. Put it in that formula. But one way or another, you've got to find the equation of the vertex, or the coordinates of the vertex might be a little bit more appropriate. In this case, it's probably easiest just to do it here. So that'd be negative of something over something. Let's see. Shauna, help me fill in the something and the something. What's A going to equal, please?
So A is going to equal 4.
Mm-hmm. And B is going to equal?
12. Oh, negative 12.
Negative 12. Perfect. So I get the negative of negative 12. It's going to be a positive 12 divided by 8. And ew, this isn't nice, is it? My vertex is a fraction. It's 3 over 2, or 1.5, or 1.5, however you want to write it. So it's not a really user-friendly number. That's okay. We can still work with it. In working with this one, you might realize to yourself, you know, I really don't feel like putting in 1.5 into here and squaring it and all that work. So maybe you want to take out some technology and use your graphing calculator. So that's going to be 1.5 goes in here, and in here, and in here. You don't have to get quite so fancy as what we did just a moment ago. But here's what it looks like if you did want to use what we did just a minute ago. So you hit the y equals key. Let's clear out everything there and type in our new equation. So it's going to be 4x squared minus 12x plus 9. So type in your equation in the equation editor. If you're watching this on video, then you might need to set up your table. So this is a one-time setting. You hit the second key, then the window key. You make sure that independent is set to ask and dependent is set to auto. With those settings in hand, hit the second key, then the table key, and this is where your calculator really can earn its money. If there's anything there, just delete it. Let's type in 1.5 for x, and the result is probably going to be a little bit surprising to you. You get a 0. Oh, that's weird. So what that means is that 1.5 actually is an x-intercept. That's odd. Well, let's kind of keep that down. Let's see. So our vertex and our x-intercepts, at least one of them are the same. So I'll make a little t-table here. 1.5 for x gives me 0 for y. All right. You could work backwards. Let's see. If I said x equals 0, let's see what I get for y. That's going to be my y-intercept. And since we've got this nice formula already set up in our calculator, let's be really, really lazy and plug in y equals 0, and we get, excuse me, x equals 0, we get y equals 9. So that's our y-intercept.
Do you always get C for the y-intercept?
If it's in this form.
Okay.
Yes, if it's in this form, you're always going to get C for the y-intercept. Yeah, because then your x squared and your x term, both of these are just going to vanish. So it's always going to be C. So 0 and 9. And maybe we should take a look at this problem a little bit on the graph. I mean, after all, this is a graphing calculator. So probably the most basic setting you can do is the standard setting. So hit the zoom key and hit zoom 6, zoom standard. Can you see anything unusual about this parabola? Something that hasn't quite happened before. Maybe we'll look at it on Desmos. So let's shut off this one and go down to example E. What's unusual about this one?
There are no x-intercepts.
There's kind of one. There's one x-intercept. So instead of getting, say, 2 x-intercepts like we do with some of the problems, like problem D gave us 2 x-intercepts, this one only gives us 1 x-intercept. That's because the graph is said to just kiss the x-axis. So if you ever take Latin, I think the word to kiss is to osculate or something like that. So this is said to osculate the x-axis. So it kisses it. It's about as romantic as math gets. Sorry. Actually, it's not quite true. There's kind of some cool shapes you can do. Like, let's do r equals 2 minus 2 cosine theta. There you go. There's a heart. Yay, isn't that special? Okay, enough of that. So really, there's only going to be 2 points that we're going to be able to find here. We're going to be able to find, I mean, real easily, you can find this point and this point. You can find the y-intercept, the vertex, and your x-intercepts are all the same. So that's really all we can do in terms of graphing. Now, there is an extra credit point that you can get off of this. Let's first of all figure out what the axis of symmetry is. Can anyone tell me what the equation for the axis of symmetry is?
X equals 3 over 2.
Yep. It's just x equals that value right there, x equals 3 over 2. So let's see, the set x equals 0, f of 0 equals 9. That's your y-intercept. That's your vertex and x-intercepts. But this is your axis of symmetry. So here's how you can pick up an extra credit question or point. If we do x equals 3 over 2, that's showing you your axis of symmetry. You've got a point over here at 9. That's 1.5 away from my axis of symmetry. What if I go 1.5 the other direction? Can anyone tell me what the coordinate would be here?
3,9.
3 and 9, perfect, because it's symmetric, right? So you get kind of a point for free. If you're trying to draw this graph freehand and you look at this and say, oh, 2 points is not enough, you've got an extra point here for free. And if you show me that point by symmetry, that's an extra credit point. I'm really happy to see that. Now, is it a requirement? No. And why is this all happening? You can probably see it better if you rewrite f of x as, in its factored form, it's 2x minus 3 times 2x minus 3. So when I set that equal to 0, instead of getting 2 different numbers, I get 1. I just get where 2x minus 3 equals 0. So that's why I'm only getting that one term. That's why you only get the one root here. It happens to be your vertex. Okay, good deal. Let's solve 1 or 2 more. So let's move on to example F. So example F. F of x, y equals 20x squared plus 21x plus 4. This one's going to be a little bit more of your typical or routine parabolas. Let's start by finding the vertex. I'm not sure I really want to spend the time putting this in that nice form that you can put things in. That would be a lot of work. I mean, it's kind of in that form here. You can see you have a plus 0. But let's find the vertex this way. X equals negative b over 2a. Ryan G. What are b and a in this one?
B is 21, A 20.
B is 21, A is 20. And this one's not looking like it's going to work out nice and even either. Negative 21 over 40. Yuck. Kind of on the ugly side there. Kind of might be an understatement. F of x is going to be f of negative 21 over 40. Here's where it's definitely handy to have a graphing calculator or to use Desmos on the internet. Negative 21 over 40. Negative 21 over 40 squared. Negative 21 over 40 plus 4. So 20 plus 21. That's really massively ugly. All right, so let's figure that out up here. X squared plus 21x plus 4. Bam. Let's take kind of a quick look at the graph just to see what it looks like. If you hit the graph key, how many places does this cross the x-axis? Twice. That means you expect 2 solutions when you look for the x-intercepts. In the last problem, we only had 1. Now, if you don't like the look at that graph, if you're like, I'd rather zoom in on that a little bit, it's a lot of wasted space, you can hit the zoom key and press enter. That does zoom box. And just draw a little box around it by moving this cursor around. Press the enter key once, drag down, drag over, press the enter key again when you get things set up the way you want, and bam, a nicer graph. All right, you don't have to be a genius in graphing these things. Let's take a look at what happens when I plug in a particular point, that is negative 21 divided by 40. And wow, you get that ugly mess up here. Negative 1.5125. All right, so that's your vertex. X and Y. Negative 21 over 40. Negative 1.5125. That's your vertex. Let's find some other points, some easier points. For instance, let's find the y-intercept. If I set x equal to 0, I get the y-intercept. Pearl, you noticed something earlier? Why don't you put it into play here? What's the y-intercept going to be?
4.
4. When the equation's in this form, y-intercept's going to be the value of c. Nice. We've got to figure out the x-intercepts. So what are we going to do to find the x-intercepts?
Set y equal to 0.
Yeah, set y equal to 0. So I'm going to set y equal to 0 here and here. Now you've got two places where you can set y equal to 0. You can set y equal to 0 here, or I think I gave you another version of this equation on your handout. Let's see, I think I have a copy of that. They're all taken up. So let's look at it here. This part right here. So what I did for you on this one is I did the work of completing the square. It's a lot of work. I don't exactly recommend it. But if you did that, you could see, the vertex, and you could use that form of the vertex to find the x-intercepts. We're not going to do that. We've got 0 equals 20x squared plus 21x plus 4. How are we going to find the solutions here? What would you do? Or if I just gave you this as an equation on a test, how would you solve it?
Factor. I don't know if you.
Yeah, but you try and you don't find it to factor. Factoring this one means you multiply the 20 times the 4, which gives you 80. Find two numbers that multiply to 80 and add to 21. They don't exist.
I use quadratic.
Yeah, if a quick try at factoring doesn't work, then you're going to use a quadratic formula. So x equals the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Not particularly fun, but it's what has to be done. Rachel, help me out with A, B, and C.
A is 20, B is 2, and C is 4. So
21 and 4, good. That's a 21, sorry. So negative of 21 plus or minus square root of 21 squared minus 4 times A, which is 20, times C, which is 4, over 2 times A. 2 times A would be 2 times 20. So negative 21 plus or minus the square root of, let's see, that'd be 441 minus 320. Someone double check me on that?
yes.
Thank you. Over 40. Negative 21 plus or minus the square root of 121. Oh, wow. I was wrong. Shame on me.
Oh, it does.
If this term turns out to be a perfect square, then your problem would have factored. But the problem is, do you really want to spend that effort trying to figure out how this thing factors?
No.
I mean, the quadratic formula works. If you're good enough to factor this, hey, you're better than me. Good on you. But, you know, I missed it. In fairness, I didn't look that hard. But this becomes plus or minus the square root of 121 over 40. This term, by the way, b squared minus 4ac is called the discriminant. And when b squared minus 4ac is greater than 0, you get two real solutions. When it equals 0, you get one solution. And when it's less than 0, you get two complex solutions. So it tells you a lot about what you're going to get when you solve the quadratic equation. Let's finish this up so we can go home. Negative 21 plus 11 over 40 gives me negative 10 over 40, which is negative 1/4. And then this one gives me negative 21 minus 11 over 40 gives me negative 32 over 40, which will eventually factor into, well, actually, no, not negative. Negative 4/5. Is that right? Negative 4/5? Thank you. Negative 4/5. So, wow. Negative 1/4, negative 4/5. Those should be our points. Let me emphasize something for your convenience. You can double check these real easily. How did I not? Let me just check here. There we go. So, negative 0.8, that's your negative 4/5. Negative 0.25, that's your negative 1/4. Here's your vertex. Now, it's not showing you the exact vertex because it only rounds to 3 decimal places. But if you're only checking it, you can check that that vertex turns out to be, let's see, 1.5125. You can write that as a fraction as 121 over 80. Perfect. Perfect. Okay, that's it for today. We'll practice a lot of this stuff on Tuesday.